Exactly what CINDI does, the instrument. Only the instrument, catches neutral particles and ionized particles.
One of the big attractions at every AGU meeting is right here in the exhibit hall. This is where all this stuff of science is on display. Scientific instruments, new data, exploration equipment of all kinds, comic books, and apparently comic book heroes.
I'm Cindy. I'm an android space girl who's also a dog catcher. In my spare time, I'm also a NASA mascot for the CINDI Coupled Ion Neutral Dynamics Investigation, a NASA mission of opportunity. So space dogs are fantastic. I have two called Tech and Tack. And space dogs are just like normal dogs, except for they can lose their tails. When they have their tails, they're calm and they're lap dogs, and they're very comfortable to have around as pets. But when energy biscuits come from the sun and the dogs eat them, their tails pop off and they start chasing them around. They're very, very jumpy and energetic. Now, my job as a dog catcher is to catch and release these dogs, and I also study their migration patterns and what heights they live at in my region of space, their temperatures, and how they move around. There are a lot of people on Earth that use my space dog data to investigate what's going on up in my levels of space. There's a group at University in Texas of Dallas that is doing this. One of the talks will be presented here at AGU by a grad student named Angeline Burrell. You should go check it out. Alright, today I'm going to use the latitude and local time variations in the field of neutral drifts to provide constraints on the lower hemispheric influence. So the talk I gave used the CINDI data, the ion velocities, and compared them to the results from a model in order to provide boundaries on the magnitude of winds lower down in the atmosphere. These winds are hard to measure, and we don't currently have any satellites measuring them at that level. So CINDI studies the ionosphere, which is the electric portion of the atmosphere. It's on board a satellite that's at the lowest 400 kilometers above the Earth. The part of CINDI that I use measures the movement, the temperature, and the type and amount of the ions that it runs across. So most of the atmosphere is neutral, it's breathable, it's made up of molecules and atoms. And it gets thinner the further you get away from the Earth. By the time you get up to the level where the satellite that we're using, CNOPS, is at, you have less than 1% of the atmosphere left. When it's this thin, it's very easy for radiation that comes from the sun to excite the particles and throw off an electron and cause an ion to be formed. And the formation of the ionosphere is what protects us from most of the sun's radiation. It absorbs a lot of the cosmic rays, the X-rays, and most of the UV radiation that comes out.
What made you decide to become a scientist?
Well, my first trip to the planetarium, really. I loved the stars and the movements and just how much we didn't know about the universe. So I decided that it was the most worthwhile and interesting thing to study. I'd always been good at math, and once I realized that I loved physics, it was a no-brainer. To find out more when you don't have a physics background can be a little bit difficult. But one way I've used to explain to my friends and family is the comic books, the CINDI comic books, CINDI in Space and CINDI in the Electric Atmosphere. They do a really good job of explaining in interesting terms and basic but relevant terms that do explain pretty much everything about what I do and about the ionosphere itself. I mean, you should go check it out.